Welcome back to Moo Math. Today we're going to look at independent and dependent events and go through our note-taking guide. Okay, independent and dependent events. These are AND problems. And in math, AND problems, one event occurs and a second event occurs. We are not going to add, we're actually going to multiply. So AND we always think of in math as adding, but we don't. And the way to remember that in probability is this: do not add. Do not add. Okay, so it's kind of an acronym to help us remember we don't add, we end up multiplying. So you're going to multiply the two probabilities together when you see AND, which is the intersection of two events. Okay, so event A occurring does not affect the probability of event B. That's an independent event. So if you flip a coin and then you draw a card, they don't affect each other. Or if you flip a coin and then pick it up again and flip it again, the first event doesn't affect the second event. So those are independent events, events that don't affect each other. Okay, so let's look at some examples of independent events. A coin is tossed and a six-sided dice is rolled. So as you can see, the coin toss and the rolling of the dice, they don't affect each other. Find the probability of landing on a head on the coin and rolling a 3 on the die. Okay, so what's the probability of landing on a head? Well, we have heads and tails, so we have two choices. So getting a head is 1 out of 2, and we're going to multiply that times, because it's an AND problem, so do not add, multiply, rolling a 3 on a dice. Well, 3 on a die is 1 chance out of 6, because we have 6 sides on a die. So we're going to multiply that together, and that just gives us 1/12. So that's the probability of that event occurring. Okay, let's look at another one. A card is chosen at random from a deck of 52 cards. It then is replaced and a second card is chosen. What's the probability of choosing a jack and an 8? Okay, well, the probability of choosing a jack, we have 4 jacks in the deck and we have 52 cards. And then it's an AND problem, so we're going to multiply, and then an 8. Well, we have 4 8s out of 52. And we replace the cards, so we still have 52 cards to choose from. So I'm just going to reduce these before I multiply them. This is going to be 1/13 times 1/13, which is 1 out of 169. And that would be my probability. Okay? So let's look at the next one. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. After replacing it, so you replace it, a second marble is chosen. What's the probability of choosing a green and a yellow? Okay, so replacement, when you do replacement, that is independent. Independent means the first event doesn't affect the second one, so you have the same number of marbles to choose from. So what's the probability of choosing the green? Well, green, we have 5 out of, let's see, that's 8, 9, 10 out of 16 times, and means do not add, multiply. Yellow is 6 out of 16. Now I'm going to go ahead and reduce. 5/16 doesn't reduce, but this reduces to 3 8. Now I can multiply, and I can get 15 out of, what's 16 times 8? 16 times 8 is 128. So there is my probability. Okay, 15 out of 128. A school survey found that 9 out of 10 students like pizza. If 3 of these are chosen at random with replacement, what's the probability that all 3 students like pizza? Okay, our first chance is a 9 out of 10. We have 9 chances out of 10, but then we do it a second time, and we put the same kids back in the jar and choose again, and third one, same probability. So we have 3 events occurring, so we have to multiply that together. That gives us 9 times 9 times 9, which is, I should know that, 729 out of 1,000. And that would be our probability. 729 times out of 1,000 tries, we would get all 3 people like you.